Numbers and letters are all around us. On our screens, on the street, and at the store. No, I'm not talking about math or even computers. I'm talking about handwritten and printed characters. Unlocking the ability for machine learning or AI models to recognize these numbers and letters has wide-ranging applications, whether it's reading postal addresses, bank check amounts, and any other type of handwritten form, not to mention allowing for the digitalization of ancient books and documents. Recently, I started a project to recognize printed expiry dates, and so recognizing printed characters was the first place to start. Take the MNIST handwritten digits dataset, for example. However, I decided to take it one step further. In this video, the first in a series on this project, we'll dive into how I generated a dataset of CAPTCHAs from scratch and got the images processed and ready for training for the AI model. All the resources that I talk about will be linked in the description below, so you can check them out afterwards if you're interested. I drew inspiration for this project from this article. First, I downloaded the source code to this WordPress CAPTCHA plugin and figured out exactly how it works. Essentially, it takes characters from a font file and applies different transformations to them, rotation, change in size, etc. The plugin makes the file name hashed so people can't find the answer that way, so instead I had to make it so that the file name was the characters present in the image. Then, I had a bit of a problem. I added characters into the mix like slash, period, and hyphen. However, as you may know, adding a slash in a file name isn't exactly allowed, as it signifies a new directory. So I masked the slash character with a caret and wrapped the characters all together, the file name, in quotation marks. Then, using the production server from my school software company, RD Systems, I created a simple page with one button that, when clicked, ran the PHP code on the backend to generate 3,000 CAPTCHA images. The dataset, though not the source code, will be linked in the description as well. I then imported this dataset of 3,000 images back to my local environment. The next step was to split up the CAPTCHAs into individual letters. For this part, I moved to Google Colab, as I'm still getting to know Python, and the Jupyter Notebook allows for amazing debugging. I used OpenCV2 to convert the image to grayscale, add extra padding around the image, convert it to pure black and white, and then find the contours of the image. To account for two or more characters that are overlapping, I added an if statement to split regions whose width is 1.1 times more than the height of the image. In other words, if the image is wider than it is tall, I split it into two separate characters. I made sure to account for if there are less than 4 characters extracted in this case, as well as if the images lack either the dimension of height or width. I had to do this after the code stopped running every single time at around 200 images, and I figured out that because I included periods in the CAPTCHAs, they were sometimes, although rarely, missed. This led to the error where either the dimension of height or width was missing. Finally, I saved each character as a numbered image per type, so like A255, so that I could see at a glance if any one character appeared more or less frequently than others for whatever reason. So essentially, that's it. I pulled the source code for the CAPTCHA generator, took the time to understand how it works, which was no more than a few hours. I generated my own dataset and then prepped the images for pre-processing. In the next video, we'll take a look at how I trained the model and even some results. In the meantime, I'll also experiment with making specific combinations of letters, numbers, and slashes to better simulate the use case for this project. Thank you for watching. Let me know what you think down in the comments below, and please do subscribe to see when I post new videos. Until next time, stay curious.